Hi guys, I hope that you're all doing well. In today's lesson, we'll attempt a past question paper. I believe that you guys have been following and watching the videos according to the playlist order. And even though I taught you guys different formulas, for example, in the distance formula, the midpoint formula, gradient formula, we also learned about parallel and perpendicular lines, as well as triangles and quadrilaterals if you texted us, as I mentioned in the previous video. So even though you guys know the information, when you write your exams, please try to be open-minded. Don't just be fixated on what you already know, and remember that there's always room to learn. So just because it's an exam doesn't mean you can treat it as an activity. So just relax, read whatever's given to you, and try to update your diagram as you answer these questions. Now, I won't lie to you guys, this is a nasty question paper. There are easy ones in which they were generous with the marks, but I just wanted to show you guys how tricky analytical geometry can get. Then for the following video, I'll most probably do a question where the question paper is a bit more approachable. So we have question 1. In the diagram below, N, R, and K are vertices of triangle NRK. N and P are the points on the x-axis and y-axis respectively. PK is drawn parallel to NR. Okay, and here's our diagram. 1.1, calculate the gradient of PK. Before we even start with our questions, I believe that it's wise to update our diagram. So let's read this again. In the diagram below, N, R, and K are vertices of triangle NRK. N and P are points on the x-axis and y-axis respectively. PK is drawn parallel to NR. PK is from here to there. So they said it's parallel to NR, so we can show those two matching arrows. Now let's start with 1.1, which says calculate the gradient of PK. Do you still remember the gradient formula? It's M is equal to y2 minus y1 all over x2 minus x1. So you have to find the gradient of PK. Let's specify is equal to. Let's label our points on the side so that we don't make any mistakes when substituting. P, we can use P as our first point and K as our second point. For P, we have 0 and 2. For K, we have 4 and negative 6. So this is our X, that is your Y, this is your X, and that is your Y. That is X1, Y1, X2, Y2. Now let's substitute. We have y2, which is negative 6, minus y1, which is 2, over x2, which is 4, minus x1, which is 0. Remember, this is on the side, okay? You can still do this in your answer sheet. But let me just erase that. When you punch this in your calculator, your answer will be, the midpoint of PK is negative 2. So our answer here is, let's say, midpoint of PK, negative 2. You can also write this in your question paper. So we're done with 1.1. Let's move to 1.2. We have determine the coordinates of N. Okay, there's your N. So there are different ways in which you can solve this. And I can see that it's worth 3 marks. And I'll show you guys the easiest method. However, if your teacher showed you a different way, or if you can think of a different way, please let me know in the comments. However, I think that we can use the straight line formula in order to find the coordinates. So remember that your straight line is y is equal to mx plus c, the standard formula, right? So they told us here that PK and NR are parallel. And what do you know about parallel lines? They have the same gradient. So that means our gradient is equal to negative 2. We found this in 1.1, okay? So you can say the gradient of PK is equal to the gradient of NR, and we can give our reason as PK is parallel to NR. Now let's substitute this gradient into our straight line formula. This will be y is equal to, our m is negative 2. We then have x plus c. When dealing with straight lines, remember I told you in the previous video that you can substitute any point that's related to the 2 points that you have to deal with. We do not know what the coordinates of n are, so we can choose r. So for r, we have 8 and -2. Remember, this 8 is your x and the -2 is your y. So you can write this on the side. I'm just going to erase this right now. So where we see y, we have to substitute our -2 is equal to -2. What is your x? It's 8 plus c. So we'll say -2 is equal to -2 times 8, which is -16 plus c. Let's take this -16 that side. We'll have -2 plus 16 is equal to c. -2 plus 16 is 14. Therefore, c is equal to 14. So our full equation, or our updated straight line formula, will be y is equal to -2x plus 14. So can you guys see that at point N, it lies on the x-intercept? So when it lies on the x-intercept, let's say x-intercept, let's let y to be 0. And they told us here in the statement that N and P are points that lie on the x-axis and the y-axis respectively. So here we can see that N is on the x-axis. 0 is equal to -2x plus 14. Now let's take this 14 that side. This will be -14 is equal to -2x. So we can divide both sides by -2 to get rid of that. X is equal to, what is -14 divided by -2? Your answer will be 7. So the coordinates will be, the coordinates of N will be 7. We calculated this here, and 0, because you let y to be 0. This video is proudly brought to you by McDonald's. Download the McDonald's app today and start earning points every time you order your favorite meals. The more points you collect, the closer you get to exciting rewards like free burgers, desserts, drinks, and more. Simply order through the app, collect points, and redeem them for delicious treats once you've reached the required threshold. Get the McDonald's app now for more information and start enjoying rewards with every bite. Let's move to 1.3. It says determine the length of KR. What do you guys use to determine the length? The distance formula, which is you open a square root. In the first bracket you have x2 minus x1 squared plus y2 minus y1 squared. We then close a bracket, your square root. Now let's substitute. Let's label our coordinates. We have k. What are the coordinates of k? 4 and -6. What's the other point? We have r, which is 8 and -2. This one's very straightforward. So that 4 is your x, the -6 is your y, that 8 is your x, and that -2 is your y. That will be x1, y1, x2, y2. Now let's substitute. We'll have, what is x2? -2. X2 is 8 minus x1, which is 4. Let's close our bracket. Then squared plus y2, which is -2 minus y1, which is -6. Make sure that it's in a bracket. You have to use square brackets to avoid making any mistakes. When you punch this in a calculator, don't make any mistakes with the brackets. Make sure that you close them 2 times in this term. Your answer will be 5.66. 1.4, we have if t, then our coordinates are k plus 1 and 3 minus k, is the midpoint of PR. Determine the coordinates of t, hence the value of k. So before we try to understand what is fully going on, I think we should focus on this, the midpoint of PR. Let's try to find the midpoint of PR. Remember, the midpoint formula is, let's say 1.4 x1 plus x2 over 2. We also have y1 plus y2 over 2. So let's label our points to avoid making any mistakes. For the first point, we can use P. which is 0 and 2. And for the second point, we can use, they said PR. So let's use R. We have 8 and negative 2. So that is your x value, that is your y value, that is your x value, and that is your y value. That will be x1, y1, x2, y2. Now let's substitute. We have x1, which is 0, plus x2, which is 8, over 2. We have y1, which is 2, plus y2, which is negative 2, all over 2. Remember, do not erase these calculations. You guys have to show them. So we have 0 plus 8 over 2. When you calculate that, or when you punch it in your calculator, your answer will be 4. And when you punch this in a calculator, your answer will be 0. The reason I wrote t there is that they told you that t is the midpoint of PR. So we should show this as t, 4, and 0. There is a new point, which is the midpoint. It's between P. Let's use a different color. It's between P and R. It's probably there. Okay? Now let's equate the given algebraic expression for point T to the calculated coordinates. Here we have 4, which is your x, and 0 as your y. We were given here, let's say t, k plus 1, and 3 minus k. So we can start with k plus 1. K plus 1 is equal to, it has to be 4. Okay? Because here, that'll be your x, and that is your y. K plus 1 is equal to 4. When you take this one that side, we'll have k is equal to 4 minus 1. Therefore, k is equal to 3. Now let's move to the y. We have 3 minus k is equal to 0. Now let's substitute this 3, okay, because you said 3 is equal to k. This will be 3 minus, that k is 3 is equal to 0. 3 minus 3 is 0, therefore 0 is equal to 0. That would mean your final answer is t 4 and this 0. So I rewrote the steps for you guys. For 1.4, label the coordinates, use the midpoint formula, compare with the given coordinates of t. Okay, so whenever you see midpoint and a point written in terms of k or any other value, first find the midpoint using the formula, then equate the coordinates to solve for k. This is the standard grade 10 analytical geometry method. Let's move to 1.5. We have determine the equation of the perpendicular bisector of PR in the form y is equal to mx plus c. Remember, y is equal to mx plus c is your straight line formula. So we have a perpendicular bisector. What do you remember about perpendicular lines? They cut each other at 90 degrees, and when you multiply the gradients, you always get a -1. So how do we answer this question? Determine the equation of the perpendicular bisector of PR. So we have to find the gradient first. Remember, y is equal to mx plus c. The m is your gradient. And you have PR. So let's try to find the gradient. Remember, the gradient formula is m is equal to y2 minus y1 over x2 minus x1. So the gradient of PR will be -2 minus 2, remember label your points, over 8 minus 0. And when you punch this in your calculator, your answer will be -1 over 2. So this is the gradient for PR, okay, as we've said here. We want to find the perpendicular bisector, meaning when we multiply this with the gradient of the perpendicular bisector, we don't know what the line is. We can just say m, we have to get a -1. And remember, I told you guys that you have to find the negative reciprocal. For example, if it's 1 over 2 it'll have to be negative 2 over 1, which is basically negative 2. So in this case, we already have negative 1 over 2. Our answer will be positive 2, because it'll be, you have a negative here, it should be positive. Then this 2 goes to your numerator, so it'll be 2 over 1, which is basically 2. But if you don't remember this in your exam, you can just substitute this in your formula. This says negative 1 over 2, m is equal to negative 1. Let's solve for m. We can solve for m by dividing both sides with negative 1 over 2 over negative 1 over 2. This will cancel with that, and your m will be 2. If you don't know how to solve equations, I'd recommend that you check out the equations playlist. It'll prepare you for questions like these. Then the link will be in the description. So the gradient of the perpendicular bisector is 2. We can show this as, let's say, m, a perpendicular symbol of 2. Now, I reminded you guys of the key properties of a perpendicular line. Now, what you guys should know about perpendicular bisectors is that it also passes through the midpoint of PR. And remember, the midpoint of PR is this point, T, the one that we calculated in the previous example. So if your T is wrong, your 1.5 will most probably be wrong as well. So for our next step, we have to substitute this point into our straight line formula. Remember, we have y is equal to mx plus c. We know the gradient y is equal to 2x plus c. Now let's substitute this point. Remember, that is your x and that is your y. So your y is 0 is equal to 2. What is your x? 4 plus c, which is 0 is equal to 2 times 4 is 8 plus c. Let's take this 8 that side, it crosses the equal sign, so it should be negative 8 is equal to c. And therefore, c is equal to negative 8. Now, we still haven't fully answered the question. It says, determine the equation of the perpendicular bisector of PR in the form y is equal to mx plus c. This will be, your final answer will be y is equal to, your gradient is 2x plus, we've calculated c, it's negative 8. So it should be 2x minus 8. So I wrote the steps for you guys on the side. For 1.5, you have to find the gradient of PR, the gradient of the perpendicular line, and substitute into the midpoint of PR, which is T. Now, how do we know that it's the midpoint is T? What you should know about perpendicular bisectors is that they pass through the midpoint of the line segment, which is T. And again, it cuts the line segment at a right angle at 90 degrees, meaning its gradient is the negative reciprocal of the line's gradient. So we have m times m is equal to negative 1. From there, you'll solve. And that is how we solve grade 10 analytical geometry. Thank you guys for watching. Please like and subscribe. I'll see you guys in the next video.